Hello friends, in this video I'd like to solve the following problem from the Pan-African Mathematics Olympiad 2000, problem number 1. We wish to solve the following equation: 1 plus cotangent of t times sine cubed of t plus 1 plus tangent of t times cosine cubed of t equals cosine of twice t, 2 times t. So my hints for this problem: first of all, remember about the assumptions about tangent and cotangent functions. They are undefined for some numbers. Then try to factorize the left-hand side of our equation. And also, this formula may be useful, namely cosine of alpha plus minus beta equals cosine of alpha, cosine of beta, minus or plus sine of alpha, sine of beta. And in particular, the corollary of this formula is that cosine of 2 times alpha equals cosine squared of alpha minus sine squared of alpha. So give this problem a try and I will see you in a minute. Okay, so I hope that you've managed to solve this equation. Let's start with our assumptions. Well, cosine is cotangent is cosine over sine. So sine of t must be non-zero, and tangent is sine over cosine. So cosine must be also not zero. And by looking at the graph of sine of cosine, it's pretty easy to see that it's equivalent to saying that t cannot be equal k times pi over 2 for any integer k. These numbers are not allowed. Okay. And now let's take our equation. Cotangent is cosine over sine times sine cubed plus, well, tangent is sine over cosine times cosine cubed of t equals cosine of 2 times t, okay? And now let's multiply everything. So we have sine cubed of t plus cosine t sine squared of t plus cosine cubed of t plus sine t cosine squared of t equals cosine of 2 times t. And now let's do the following. Well, here from the first part, here we have sine cubed and here we have sine squared. So we can factor out sine squared. Likewise, here we have cosine cubed and cosine squared. So we will be able to factor out cosine squared of t as well. And what we are left with? Here we are left with sine of t plus cosine of t. And here we have cosine of t plus sine of t. And also on the right hand side, let's use the formula for cosine of 2 times t, namely cosine squared of t minus sine squared of t. Very well. And now let's look. We have a common factor right now, namely cosine plus sine times sine squared plus cosine squared. And on the right hand side, we have, after factorization, cosine of t minus sine of t times cosine of t plus sine of t. Okay. And now, by well-known property, sine squared plus cosine squared, no matter the t, it's always 1. So we have the following equation: cosine plus sine equals cosine minus sine times cosine plus sine. Very well. And let's notice something. Namely, here we have cosine plus sine, and here we have a cosine plus sine as well. So this equation will be satisfied if this sum equals 0, Or if it's not 0, then after division, we have 1 on the left-hand side, and on the right-hand side, we have cosine minus sine. So the second possibility is that cosine minus sine equals 1. So now we have two simpler equations to be solved. And my favorite method of solving these types of equations is to multiply both sides by square root of 2 over 2. Why is that? Well, cosine of pi over 4 is square root of 2 over 2, and sine of pi over 4 is also square root of 2 over 2. So I can do the following. I can write cosine of t, cosine of pi over 4, plus sine of t, sine of pi over 4 equals 0, or the second option, after multiplication, I do the similar trick. And on the right-hand side, I write square root of 2 over 2. Okay? And now, using the formula which I suggested at the beginning of my video, this expression can be written as cosine of t minus pi over 4, while this expression can be written as cosine of t plus pi over 4 equals square root of 2 over 2. Okay, and now, when does cosine attain the value of 0? It happens if and only if its argument is, let's see, pi over 2 plus k times pi. And when does cosine attain the value of square root of 2 over 2? It attains it at pi over 4 plus 2 times k times pi. But it also attains it. It can be easily seen from the graph of cosine function. Let's move it a little bit. When the argument equals 2 pi minus pi over 4 plus, running out of space again, oh no, pi over 4 plus 2k times pi, where k is an integer. Okay, and now let's solve it, simplify it. T equals 3 pi over 4 plus k times pi, it's one option. The second option is t equals 2k pi, or the third option, t equals 3 pi over 2 plus 2k times pi. But let's notice that we have to confront our results with our solution. This number and this number works just fine. Or does it? Or does it? Well, let's look at our assumption. T must be different than k pi over 2. And that means that we cannot have any number of the form 3 pi over 2. So this number does not work, and this number also doesn't work. These numbers are outside of our domain. So finally, we have only one option, namely t must be equal 3 pi over 4 plus k times pi, where k is any integer whatsoever. And that closes our solution. Thank you for watching, and I will see you next time. Goodbye.